Is it recording? It's going. Okay, everybody, let's do a tangent plane.
No! No!
You guys are so good. That was really brilliant. All right, so let's do this tangent plane problem. No, I can't stand it. It's so much fun. All right, here we go. What the heck? Oh, I have the camera upside down. There we go. All right. So the surface looks like this. It's a hyperboloid of one sheet. And we're going to do the partials. So I need the partial. Oh, and what's your point? What's the point? 223. Let's just see. Okay, so the equation is, what's the equation? I need the equation.
Z squared plus 9. Z squared equals.
Plus x squared?
Yes. Minus y squared.
Minus y squared. All right, so 2, that's 4. 2, they cancel. Yes, that point is on this. That point is on this surface. All right, so, and it's on the top half. So we get to use our partials, z sub x and z sub y, evaluated at the point 223, but it's really going to be the point 22. The z doesn't enter into it. Who's got this first partial? Lay it on me. How about Jared?
Me, I did the last one.
Oh, damn it. He gives it all away. I want you to be a genius. So you're just shot at being a genius, dude. Okay, so it's 1/2 9 plus x squared minus y squared to the negative 1/2 times 2x. This guy's the same thing except minus 2y on the end. So now my slopes.
You forgot the minus negative.
Thank you. So z sub x at 2, 2, z sub y at 2, 2. All you do is pop them in there. So I've got, that turns into a 3, but it's to the negative 1. It's going to be the negative 1 power. So I have 1/6, and then 2 times 2 is 4. So I have 2/3. This one, I have that extra minus sign surviving. This turns into 1/6. But then you can cancel a 2. Is it negative 1, negative 2/3? Did I do okay? I did a lot in my head there. So I'm trying to get done in 4 minutes. The 2's basically cancel in here because it's 2 squared minus 2 squared. 9 to the negative 1/2 is 1/3. 1/6 times negative 2 is negative 1/3. It's negative 1/3, isn't it? Oh, but it's times y, and y is 2, so negative 2/3 is right. All right, let me get this limit problem out of here. I'll talk that through with the camera when we're all done with this problem. Okay, so these are my two slopes. I'm ready for my answer. Here's the answer. Z minus the z coordinate is equal to the slope for x, which turned out to be 2/3. X minus the x coordinate minus, this is the slope of the y, times the y minus the y coordinate. And that's it. That's full credit for me. Simplify to match the book answer, and that's what happens. I'm going to record myself doing that limit on the board for Alex. But you guys are dismissed. If you want to hang around while I'm going to just do the problem I already did. It's already on the board. But that gives me my last problem done. And I have a record of you guys. It's going to be week 4, day 3. Here, I'll write it down for you. It's going to be 231fa21 week 4, day 3 on YouTube, spelled out just like that. Only week with a K.
Yeah.
There we go. That's what I do for all the file names. And there's years worth of videos on there with the ferret if you want to see the ferret. She's in 20 videos. All right, so Alex, this is just for you. We're doing this last problem here. We're going to be doing limits. It's x, y approaches 0, 0. And what you do is you choose a curve that contains 0, 0 that allows you to lose a variable. So the x, y going to 0, 0 becomes just x going to 0. Or sorry, x going to 0. Let's make it y. Because y equals x. One of them goes to 0, the other one goes to 0. Then the x's all cancel and you get the limit is 3. So then, here's another line, x equals 0 contains the point 0, 0. But x equals 0 turns the whole numerator to 0, but the denominator isn't. So we're doing as y approaches 0, because x is already 0, and we get 0. But these two limits are not the same, which implies that this limit does not exist. Because if the limit existed, it wouldn't matter which direction you go to get the limit. Whatever direction you go, you should get the same z number. But here we don't get the same z number because the limit doesn't exist at 0, 0. What actually happens is the surface has a lot of breaks going on. And you get different z coordinates depending on which direction you're coming from. So depending on which direction you're coming from, you get these different z coordinates, which means at 0, 0, the function is broken. It's fragmented. So that's what, and we can discover that. We get all these different slopes depending on which way we come in. So that's what's going on.